Hello and welcome to another tutorial. In this tutorial we are going to talk about the sine rule. The sine rule is one of the interesting rules that helps you to find the missing angles or missing sides in any triangle. The sine rule works on all types of triangles. It's not only for right angle triangles, it works for all the types of triangles, and it always helps you to find the missing angles and missing sides in a very easy way. We can use these rules for the missing sides and missing angles in the previous lessons. Previously we learned how to use sine and cosine and tangent, generally trigonometrics, and they used to work only on right angle triangles, but from now on this rule works for all types of triangles and helps to find missing angles and missing sides. Let's see how this works. So as you see in this triangle, angle B is opposite B small, angle C is opposite C small, and angle A is opposite A small. So the side divided by the opposite angle sine is equal to the other side divided by its opposite angle sine. As you see here, A over sine of angle A is equal to B over sine of angle B, and it's equal to C over sine of angle C. Usually we use two of them in each equation. So rarely we use three of them, but what we use in the questions that will come, we use usually only two of them. So which ones we need, we might use this two or this two or this two. They're all fine. We don't use all of them together. So similarly, when we say A over sine of A is equal to B over sine of B, so the upside down, the flipped version of this equation is still true. Sine of A divided by A, which is the side opposited, is equal to sine of B divided by B. So what's the difference between these two? When we have missing sides, as you see, we will use this one for missing sides. Why? Because the sides are on the top. And when we have missing angles, we're going to use this. We use this to find missing angles. As you see, the sign of the angle is on the top. Although we can use both to find missing angles and missing sides. Even we can find missing angles from this rule. Even we can find missing sides here, but it's easier when the sides are missing. We use this version that has the signs on the top. And when the angles are missing, this one is easier to use. While both of them work perfectly and both of them can give you missing sides and missing angles. Okay, let's go to the exercise. Question 1 here. Here we go. Question 1, we need to find side C. What's given is angle A and its opposite, angle C, and the opposite of C is missing. Angle B is not given, and the side opposite B is not given, so it means we don't care about B over sine of B. What's missing is side, so we start like C over sine of C is equal to C over sine of C. Let's straight away write the angle. C over sine of 42 is equal to, what's given is 8 over sine of 57. Now in this equation only one side is missing, so it's manageable. We can find the missing side. Now to find C, let's find angle sine of 42. Then sine of 42 is equal to this decimal. And to find C, we have to multiply this result by 8 and then divide the result of multiplying sine of 42 by 8 by sine of 57. It straight away gives sine of C. Let's do the first exercise a little bit in a longer way. Then what's coming next? C, which is the side C, is equal to 8 times sine of 42. Then the result divide by sine of 57. We learned how to do this. In this equation, we made C the subject. As you see, C is alone on the side. And this side is just calculation. We can do it with calculator. There's no any missing in this side. There are only numbers, and on the side we have C. Then let's type this in the calculator, and straight away we get the length of C. Here, we got sine of 42 is equal to this. This one should be multiplied by 8. That gives 5.35. And this result, we divided by sine of 57. So done. Side C is 6.38. 6.38, simply we can say it is 6.4 centimeters. Then C small is 6.4 centimeters. Question 2. C is not given, and the side opposite C is not given, so we don't care about C. What we need is B over sine of B is equal to 10 over sine of 52. So let's write. B over sine of 81. Look, this rule works for all types of triangles. There is no any right angle and the rule works. B over sine of 81, look, B is opposite the 81, is equal to 10, which is this side, opposite the 52. 10 over sine of 52. How can we get B? B is equal to 10 times sine of 81, and this result divided by sine of 52. So we're going to type this in the calculator, and it gives the length of B. Sine of 81 is equal to this, should be multiplied by 10, and the result should be divided by sine of 52. Here we go, it's 12.5. B small is, for question 2, B is 12.5 centimeters. Question 3, we need to find this B. Okay, then B, the opposite of B is angle 67. B over sine of 67 is equal to 5 over sine of 63. Now to find B, we always multiply the denominator of the missing by the numerator on the other side of the equal sign. Then 5 times sine of 67 over sine of 63, it gives B. Then grab the calculator, 5 times sine of 67 is equal to 4.60, and this result should be divided by sine of 63. That gives 5.16. This 6 can make this one 2 if we round it to one decimal place. Then simply B is 5.2 centimeters. B is 5.2 centimeters. Now question 4, same idea. Two angles are given, one side is given, one side is missing. So question 4, 5, 6 are your tasks. You do them. For questions 7 to 10, we need to sketch the triangle and then find the missing side. Then in triangle ABC, A is 61 degrees, B is 47 degrees. So we can roughly sketch a triangle. It's not to scale, it's just to help us which side is missing, which angle should be used. Let's call this A, B, and here C. It's fine however you named, it's so fine. You always get the same result. Angle A is 61 degrees. Angle B is 47. And AC is the opposite of B. AC is 7.2. And that's it. Find BC. BC is the missing side. Now look at this triangle. As you see, angle B is given with its opposite, and angle A is given, its opposite is missing. Angle C with its opposite are not given. We don't care about C. So let's find this missing side. We can find this missing side by following the sine rule. So what's the name of the side? It's A small because it's opposite A capital. Name doesn't matter, but let's name it the same way that we used to. Then side A over sine of 61, which is the opposite angle according to A, is equal to 7.2, which is B small, side B, opposite angle B, sine of 47. Then to find A, we say 7.2 times sine of 61, and this result over sine of 47. Now let's type this in the calculator and get the length of A small, or as the question says, the length of BC. Now 7.2, if we want to exactly type the same thing, it's fine and it's better. I recommend this way. 7.2 times sine of 61, close the bracket. We have the exact same thing, 7.2 times sine of 61, and in the denominator we have sine of 47. As you see, we copied the exact same calculation here, and we got 8.61. Simply it's 8.6. So A small, which is side BC, for this question, BC is 8.6 centimeters. Similarly, we can get the rest. For these questions, all you have to do just roughly sketch something freehand. It's also fine if you don't use ruler, just to see which angles are given, which side is missing, and what should you use in the rule. Now from question 11, you see this time the sides are given. What's missing is the angle. So to find the angle, the missing angles, we're going to put the sine on the top, the sides in the denominator. Let's do this question 11. Question 11, this angle, this is angle C. So we can say sine of C. Sine of C means sine of angle C. This is the C capital over the opposite of this angle is 8. So sine of angle C over 8 is equal to sine of 47 over 10. 10 is the opposite of the 47. Okay, similarly, to find sine of C, we will multiply 8 by sine of 47. Then the result divide by 10. So C, sine of C is 8 times sine of 47, and this result divide by 10. Eight times sine of 47 was the bracket, and the denominator is 10. 8 times sine of 47 over 10. It's correct. It's 0.5850. Then how can we use this number to get the angle C? So as you know, when we know the result of the sine, but we don't know the angle, we need to use sine inverse. Then sine inverse of the previous answer, that was 0.58 something. So that gives 35.8. So angle C is 35.8 degrees, or to the nearest whole number, it will be 36 degrees. So angle C, remember the sine inverse should be used. Angle C is 35.8 degrees. The only difference between missing side or missing angle, in the missing angle, we have to use sine inverse after we did this step. Now question 12. Again, this angle is missing. Its opposite is 72. Then sine of C, this is angle C, over its opposite, which is 72, is equal to sine of 71. Look, when we have sine on the top, on the other side we must have sine on the top. Sine of 71 over its opposite is 100. Then to get sine of C, we multiply 72 by sine of 71. And then this result divide by 100. Since what's missing is angle, not side, after we calculated this side, we need to take the sine inverse of the result to get angle C. (72) times sine of 71 over 100. This is equal to 0.68. And to get angle C, we need to find sine inverse of this result. Then shift and sine, it is sine inverse with this tiny negative one here. Sine inverse of the answer. The answer was the result of this calculation. The result of this calculation was in the answer command we used here. It gives 42.9. We can say angle C is nearly 43, or you can just copy 42.9. So angle C, this C is this C capital. Angle C is 42.9 or nearly 43 degrees. In the next questions, the same idea is repeating. Two sides are given, one angle is given, and one angle is missing. As you see, these triangles, some of them are isosceles, some of them are right angled, and the rule works perfectly. In question 15, this time two angles are missing, and we need to find them. To do this, look, it looks confusing, but we're gonna use the rule to find one angle. And what we know about triangle, all the three angles together, they must add up to 180. This will help us to find the third angle. Now here, let's clarify what we have. We have this angle S and its opposite. So we can use this in the rule. We have angle T, but angle T has no opposite. So there is no any benefit of using T because the angle and the opposite side are not given. So we cannot find T or its opposite by using the sine rule. But when you look at the R, the angle is not given, but the opposite side is given. This will help us. For R, the angle is not given, but its opposite side is given. So we're going to use these two sides with their opposite angles sine. What's missing is angle, so the sine should go to the top. Then sine of R over its opposite is 7 is equal to sine of 96 over 12. Okay, to find sine of R, 7 should be multiplied by sine of 96 and the result divide by 12. And sine of R is equal to 7 times sine of 96 all over 12. 7 times sine of 96 all over 12. This is equal to this, 0.580. Then what's missing is angle. We need to take sine inverse of this number. Then sine inverse of the answer is 35.4. Angle R is 35.4. So simply we can say it's 35.5 because after the 4 we have 6. That can make the 4, 5. Then angle R in question 15, angle R, as you see, it's 35.5 degrees. 35.5 degrees. Then how does this help to find angle T? Angle T is equal to the sum of these two angles subtracted from 180. Angle T is 180 minus 96 plus 35.5. 180 minus 96 plus 35.5. So it's 48.5. Angle T is 48.5. So we got both missing angles. That's it. The question doesn't ask this missing side. We don't have to find it. Even if the question asks, we can find it because we know the angle opposite of it, and we can use one of the other sides in the rule that will lead us to find even this missing side opposite T. Question 16 is your task. Question 17. One angle with its opposite, fine. One angle is missing and its opposite is also missing. What should we do? Good, it doesn't look like the ordinary questions that we did before. Then in this case, the question doesn't ask for angle A, but we must find it. We must find angle A, then it will help us to find angle C, and then angle C helps us to find the opposite. Looks like a long story, but now you are able to do this because we understood sine rule and we used sine rule. Now let's do this question 17. And in this page, this question is the most important because the best idea of using sine rule is in this question. To start this, we start by finding angle A. Then to find angle A, angle is missing, then sine of A over its opposite is 6.5. it's equal to sine of 67. Opposite of 67 is 8 over 8. Now, through this, we're going to find angle A. Then, we know the sum of all the angles in triangle is equal to 180. Then angle A with this 67, they help to find C. Then angle C itself helps to find the opposite of it. But the opposite of it is not necessary in this question. Then angle A helps to find angle C. Sine of A, we can find it by multiplying 6.5 by sine of 67, and the result divide by 8. 6.5 times sine of 67 over 8. So this is equal to 0.747. Then to get angle A, we need to find the sine inverse of this. Then sine inverse of this answer is 48.4. So angle A is 48.4 degrees. Angle A is 48.4 degrees. Then how can we find C? 48.4 plus 67, then take out the result from 180. 48.4 plus 67 is equal to this, and this result subtracted from 180, that gives 64.6. So angle C, which is required in this question, is 64.6 degrees. If the question asked for the side C small, then we could use the sine of this angle, C small over the sine of this angle is equal to 8 over the sine of 67, just like the previous questions, like question 1, 2, 3. Question 18, this is 118 degrees and its opposite. This angle is missing, its opposite is given, so it's like question 11. It's an easy case. And just like the questions that needs graph, for these questions 19, 20, 21, 22, just sketch something freehand, roughly draw a triangle, write the angles in their correct place, then you see which angles are given, which sides are given, then what to do to find the missing angle. Let's do question 19, and the rest are your tasks. Feel free to ask any question. Comment below with the time if you find something not clear or if something is difficult for you. So comment in this time, I have this question, why the C is this much, why we took sine inverse. Feel free to ask any question. Question 19, triangle ABC. Triangle ABC, any triangle is okay, because the question doesn't specify the triangle. We're gonna call it ABC. You can change this order, you can name it like this, ABC, but you can't say ACB. ABC, 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 any order is fine. Angle A is 62. This is 62 degrees. BC is 8 centimeters. AB is 7 centimeters. Find angle C. So angle B and its opposite are not given, means we are not going to use B or the opposite of B. Angle C is missing, then sine of C over its opposite, which is 7, is equal to sine of 62 over 8. Now to find sine of C, we're going to multiply 7 by sine of 62 and the result divide by 8. Seven times sine of 62, this result over 8, that gives 0.7725. Then what's missing is angle. We need to use sine inverse of the answer. Got it, 50.5. Angle C in this triangle, angle C is 50.5 degrees. Then in this question 19, angle C is 50.58, so we can say it's 50.6 degrees. If you round it to the nearest whole number, it will be 51. That was all about using sine rule. I hope you find it easy. Thank you for watching. And remember to write your name to confirm your attendance. Thank you for watching.